So for these four movements, it will be with the cervical vertebral joint, which is amphiarthroidal, and the degree of movement for all four of them is limited because it's amphiarthroidal. So for the first movement, it is flexion, so forward bending of the spine, and this is done in the sagittal plane, rotating around the x-axis, because the x-axis would cross his body right here. Um, and the next one would be the extension of the cervical vertebrae, and it's the same as flexion. It is over the x-axis and in the sagittal plane. And now for the cervical lateral flexion, this movement would be the side bending. So because lateral means to the side bending of the spine, and this is done in the frontal plane and rotating around the z-axis. And for the last one, cervical rotation, this is done in the transverse plane because the transverse plane is right here, and it is rotating around the y-axis because the y-axis would start right here and go all the way down. And it's a rotation movement.
The next joint that we're going to be describing is going to be in the wrist. The specific joint name is the radiocarpal joint. This is a diarthrodial joint, specifically called an ellipsoidal joint. The first motion that you can get out of this is wrist flexion. This happens on the sagittal plane, rotating around the x-axis. The opposing motion from this is wrist extension, which also happens on the sagittal plane and around the x-axis. Another motion that happens in the wrist is going to be ulnar deviation, which is also an adduction towards the body. It happens on the frontal plane around the z-axis, and the opposing motion for that one is going to be radial deviation, which is an adduction away from the body, also on the frontal plane around the z-axis. And this joint is going to be a biaxial joint, 2 degrees of freedom.
Next joint will be over the glenohumeral joint, which is your shoulder joint, and I will be describing 6 different movements with 3 planes and 3 axes that rotates around because this is a triaxial joint. So the first movement is shoulder flexion, and as you can see, shoulder flexion is in the sagittal plane, so the median plane, and it is rotating around the x-axis. So if you had an axis right here, it is rotating around that. And the other movement is the shoulder extension, which is the exact opposite direction. Everything about that is the same. If I didn't say yet, the shoulder joint is a ball and socket joint because it is diarthroidal. And so the second movement is shoulder abduction, which the body is moving away. The arm is moving away from the body, and it is in the frontal plane, which runs this way. It would be running like right through them that way. And do it again, and it rotates around the z-axis. And now the other one is adduction. So it's coming into the body, and it's the same thing. It is rotating around the frontal. It is in the frontal plane, and it's rotating around the z-axis. The third movement is the shoulder lateral rotation. So the book has it more like that, but looking at it from anatomical position, it is like that, and so it would be rotating in the transverse plane around the y-axis because the y-axis runs from down here. So if he's going like that, because you do it in anatomical, and so in anatomical position, it would be around the y-axis. And if I didn't say it yet, this is triaxial because there are 3 degrees of motion, 3 planes, and 3 axes.
The joint, the elbow joint, this is happening at the humeral ulnar joint, and which is a diarthrodial hinge joint. The motions that occur happen on the sagittal plane, moving around the x-axis. These movements are going to be called elbow flexion and also elbow extension, which is back down, the opposite motion. And this joint has 1 degree of freedom. Another form of motion happening in the arm, this is in the forearm specifically. It's the radioulnar joint. which is diathrodial pivot joint. And the motions that happen in this are going to be supination and pronation, which happen on the transverse plane around the y-axis from anatomical position. And this joint is uniaxial, which means that it just has 1 degree of freedom.
All right, and now for these next two movements, we are going to look at the thoracic vertebrae in the spinal cord. And the spinal cord, all the vertebrae are amphithyroidal, and they are limited. So though this is going to be a thoracic movement, the other vertebrae might be involved just a little bit. But for the most part, the first movement is trunk rotation, and his thoracic is mainly involved, and it is rotating along the transverse plane and rotating around the y-axis. And if you see, do it one more time. It is mainly a thoracic vertebrae, but as we get down there, you can start to see that the lumbar vertebrae are also rotating some. The next movement is lateral flexion, which is just side bending, because lateral means side bending. And this is along the frontal plane, and this is rotating around a z-axis. And the degree of movement is limited because it's amphithyroidal.
Also happening in the back, involving thoracic and lumbar vertebral joints, but primarily the lumbar vertebral joints, so the lower back, which is also an amphithyroidal joint, meaning it has limited movement, is going to be trunk flexion, which is moving downwards, and that's happening on the sagittal plane, cutting his body into left and right halves, rotating around the x-axis. And then also, we're going to have trunk extension, moving backwards like that.
For these next 6 movements, we'll be going over the hip joint, which is where the ball of the femur connects into the socket called the acetabulum. So the joint is called the femoral. The joint is called the acetabulo-femoral. And we're going to go over 6 movements because it's a ball and socket joint and it's triaxial, so it can do a variety of stuff. The first one will be hip abduction, which is done in the frontal plane because he stays in that plane of motion, and it is rotating around the z-axis. And the next movement is hip adduction, which, see, he's moving towards the body, and it is in the same plane as hip abduction, which was frontal and around the z-axis. And now for the second plane and second axis is hip flexion. So you gotta go ahead and bring your hip up. That, turn this way again, not turn towards the camera. That is in the sagittal plane because the sagittal plane goes that way. And it is rotating around the x-axis. And now for hip extension, it is the opposite of flexion, it's extension, so the angle of the joint is increasing, and that is also in the sagittal and x-axis. And now for the last one, because you could sit down, this one is hip medial rotation, which is moving inside, medial towards the body. And this is done, if you think from an anatomical position, this would be done in the transverse plane because he'd be standing and rotating that way. And thus it'd be rotating around the y-axis, which would go up and down. And the last movement is hip lateral rotation, and the hip goes out. And this is also done in the transverse plane and the y-axis. And if I forgot, the hip joint is a triaxial third degree of movement.
Also occurring on the leg is going to be our knee joint, more specifically called our tibiofemoral joint. It's a diarthrodial hinge joint, meaning it's uniaxial, moves around one plane of motion, has 1 degree of freedom. This is going to move on the sagittal plane around the x-axis, and the movements involved are going to be knee flexion and also knee extension.
We'll be looking at the ankle joint, and we'll be looking at dorsiflexion and plantar flexion. And now there's a lot happening at the ankle joint, but for our purpose, we will be assuming that it is the talocrural that has the most contribution to both of these movements. And the talocrural is functionally a hinge joint and is diarthroidal. And so, could you do dorsiflexion for me? So dorsiflexion happens in the sagittal plane and the x-axis, and it's essentially flexion of the ankle. We just call it dorsiflexion. And the other one is plantar flexion, which is essentially extension of the ankle, but it's called plantar flexion. And this is also in the sagittal plane because it's down the midline of his body and it's rotating around an x-axis. And assuming that it is a hinge joint, it is for degree of movement is 1 degree and it's uniaxial.
So motions happening in our foot are going to come from the subtalar joint. It's a diarthrodial joint, more specifically a plane joint, which gives a gliding motion. And this is the different motions that can happen in this, the first two are going to be ankle inversion and eversion. Inversion's moving in like that towards him, eversion's moving outwards away from him, and this is going to be happening on the horizontal or transverse plane, rotating around the y-axis, which the y-axis would be his second toe. So originally the y-axis would look like it's towards his body, but based off this perspective, it's going to be more aligned with the foot and with the toe. And then there's also going to be ankle abduction and adduction. And this is going to happen on the frontal plane, rotating around the z-axis. And this, the plane joint is going to be it's going to have 2 degrees of freedom.